Okay, good afternoon. Welcome to part 2 of the lecture. For the Thursday group, yes, you should be looking at this part of the lecture. So we'll continue from where we left off the last time. Okay, we were at this part where we said that the expansion is only valid when the modulus of fx is less than 2. So, question, why are the values of x restricted? Okay, so let's look at an example. If I have the expansion 1 minus x to the power of minus 1, I'll have 1 plus x squared plus x cubed and so on. So when x is, okay, so for this question, right, so when x is equals to 0.1, I will see that 1 minus 0.1 to the power of minus 1 is actually 0.9 to the power of minus 1. So if I calculate the value, I will have 1.11111 and so on, okay, which is a recurring decimal. So if I use the expansion to calculate, okay, what is the value of 1 minus x to the power minus 1, I will see that, okay, if x is equals to 0.1, I will have 1 plus 0.1 plus 0.01 plus 0.001 and so on. Okay, so you can see that the expansion approaches the actual value as we take more terms. Okay, when the value of x is between minus 1 and 1. Okay, so what if the value of x is not within this range? Because for the expansion of 1 minus x to the power minus 1, the restriction on x would be mod x less than 1, right? So x must be between 1 and minus 1. So in this case, our x is equal to 0.1, which is still within this range. So let's take a look at what if x is not within this range. Okay, so if we look at x equals to 10, okay, we will have 1 minus 10 to the power minus 1, which is minus 9 to the power of minus 1, which is 0.11111 and so on. So what would the expansion give us? If we substitute x equals to 10 in the expansion, we will have 1 plus 10 plus 100 plus 1000. So this expansion actually diverges. Okay, so therefore this expansion formula only works when you have the value of x to be between 1 and minus 1. Okay, so we go on to the next point. So your expansion is only valid when mod x less than 1 or x is between minus 1 and 1. So we look at an example 4. Obtain the first 4 terms in the expansion in ascending powers of x. Okay, for 1 over 3 minus x to the power 3, stating the set of values of x for which the expansion is valid. So we recall the formula for binomial expansion. Okay, in your working, you don't really need to write this. I'm just writing this so that you can see the formula as we go along. So this is the formula. Okay, and our expansion is 3 minus x to the power minus 3. So you can see that we need to start from 1. So when I have a 3 here, what I need to do is I need to factorize out the 3. Okay, so after I factorize out the 3, okay, this is what I have. Okay, 3 to the power of minus 3 times 1 minus x over 3 to the power minus 3. Okay, so if I look at, okay, so 3 to the power minus 3 will give me 1 over 27. And 1 minus x over 3, okay, you look at the formula, it will start with 1 plus nx. In this case, n is minus 3. Okay, and your x is actually this term over here, which is minus x over 3. Okay, so we go on to the next term, n times n minus 1. So n is minus 3, so n minus 1 will be minus 4 over 2 factorial multiply by x squared, and in this case x is minus 3 over 2, and then square. Okay, so we want the first 4 terms in the expansion. So we have got 3 terms already, so 1 more term to go. So the next term will be n times n minus 1 times n minus 2. So it will be minus 3 times minus 4 times minus 5 over 3 factorial, okay, times minus x over 3 cubed, and so on. Okay, we put a dot 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 behind because the expansion is not over yet. We are just stopping here, but the expansion is not completed, but we just decided to stop here. Okay, so simplifying, okay, this is what I will get, and if I multiply 1 over 27 in, I will get this. Okay, so the next part of the question, we are supposed to state the set of values of x for which the expansion is valid. So if we look at the expansion, okay, this is the expansion that we need to look at, the one that starts from 1. Okay, this expansion is valid only when the modulus of x over 3 is less than 1. Okay, so the expansion is valid if I have modulus of minus x over 3 less than 1. Okay, which is the same as modulus of x over 3 less than 1. Okay, so if I bring a 3 over, I will have modulus of x less than 3. And again, okay, same as before, this would mean that my x is between minus 3 and 3. Okay, it is good to write it in terms of x instead of modulus x, because, okay, the question asks for the set of values of x, not the set of values of modulus x. So you should always leave your answer as x between something and something. Okay, that's all for example 4. Now we go on to example 5.